All right, hello. Welcome back to another data structures video. Today I'm going to be implementing a queue in Python. Now, this is not something that you'll ever really do, or have a need to do, I should say. The only reason you would do it is either to learn a little bit about queues and sort of understand their methods a bit better, or because you have some assignment in school where you have to implement a queue and you came here for some help. If you ever actually want to use a queue in Python, you should use the following. From collections, import DQ. And DQ stands for double-ended queue, and it's optimized to use. It's optimized to access the front and rear of a queue. Typically in Python, whenever there's something that's already built into the language, you'll want to use that because it's going to be more efficient. Oftentimes they're written in C, so you just can't really compete to that with implementing something in Python. But for the queue, let's get started. The queue that we're going to be implementing has the following methods. A constructor, an enqueue to add, dq to remove, a front to get the very first element, a rear to get the very last element, a size, which returns the current size, and then an isFull and an isEmpty. So let's get right to it. The init is basically just going to set up the queue. So you can see here we're passing an optional capacity. So we're just going to set that as an attribute of the class. So self.capacity is equal to capacity. And then we're going to set up the elements to be an empty list. The easiest way to create a queue is just to store everything in a list. So then we're going to get to the enqueue method. Now, the enqueue method has a precondition, which is that it can't be full yet. So if the queue is already full, we're not going to be able to add to it, obviously. So we're going to check if self.isFull. Then we're going to raise a runtime error which says cannot add to full queue. But then if the queue is not empty or is not full, then we're simply just going to add to our elements. So self.elements.append lm. And that'll go ahead and add it to the very end of the list. So if we have a x, y, z, if this is our list, and we add an A, it will be added back here. So now that is our enqueue done. Now our DQ also has a precondition, and that is the queue cannot be empty. So if the queue is empty, then we're going to raise another runtime error, which says cannot DQ from empty queue. And then now we know that the DQ or that the queue is not empty if we've gotten past that point, so we can safely remove from the elements. Now, the DQ method, as I said in my last video, if you haven't checked that out, go ahead and check it out. The last video goes over some basic things about queues. Now, the DQ method simply removes from the very front of the list or the queue and returns that element. So you're shortening the list, you're shortening the queue, and you're returning the element at the same time. So here you're going to return self.elements.pop, and we're going to pop the very first element. So now, like I demonstrated with the enqueue, if you have your x, y, and z, you're going to take, and these are your elements, and you pop the first element. It means that you're going to remove x and return it, which is exactly what we want for a DQ method. So now, the next methods are a bit simpler. Well, they're all pretty simple, but front is essentially going to do the exact same thing as DQ, except it's not going to remove it from the list. So front is just going to return the very first element. So just like DQ, we cannot front an empty list. So if it is empty, we're going to raise a runtime error, which says cannot call front on an empty queue. Easy as that. And then we're just going to return self.elements element 0. Beautiful. Rear is just as simple. We're still going to check if it's empty. And then we're going to raise a runtime error, which says cannot call rear on an empty queue. So now we can safely return the rear. And what rear does is if we have our X, Y, and Z, it'll just return Z here. So it'll return the very last element in our queue. So here we'll return self.elements -1. Now, it seems like this is very simple, and it is, because Python is quite an easy language with their lists. They're very easy to access, like the last element, or just pop a random location. If you're writing this in another language, it may be a little more complicated. So here you may have to say like remove self.elements at index self.elements, the length -1. But fortunately, in Python, accessing lists is extremely easy. So we can just return the last element. Now, the size, equally as easy. We're just going to return the length of our elements. So if we have our XYZ, the length of this list is 3, so the length of our queue will also be 3. Well, the size of our queue. And now isFull is going to be extremely simple as well. We're going to return. Now, because our capacity is optional, if our capacity is not given, or it's none, it means that our queue will never be full. So we're going to say return self.capacity is not none, and self.capacity, and self.size is greater than or equal to self.capacity. So now here, if self.capacity is none, that means that isFull will never be true. And also, our size has to be greater than or equal to the capacity. Now, realistically, there should never be a time where our size is greater than our capacity, because we're protecting for that in our enqueue. But in Python, you can access whatever you want in any class. So if our capacity is changed somehow on the outside, or our elements are added to in a way that they shouldn't be by the user, we're just going to check if they're greater than to be safe. And now isEmpty is also very simple. We're just going to return if self.size is 0. It'll never be negative because lists don't work that way. And there you go. This is our queue. If you want to take a look at the whole finished product, there you have it. And now here I have a very quick demo. It doesn't cover every method that we created, but it covers the enqueue and dequeue and isEmpty. So essentially what it does is it loops through all the numbers from 0 to 9, adds them to the queue, and then it removes them all one by one and prints them. So you should see, since range goes 1, 2, 3, 4, 5, 6, 7, 8, 9, because a queue is first in, first out, they should be returned from the queue in the same order. And then at the very end, we check that it's empty because dequeue should also remove them. So if we play this, you see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the queue is empty. So you see that the queue was returning items in the correct order, and our isEmpty method is working because the dequeue method was removing elements from our queue. Hopefully this was helpful. I will have a link in the description to my data structures video. Feel free to like, comment, and subscribe. I'm posting data structures and computer science related videos every week. If you have anything that you want me to cover, feel free to leave them in the comments and I'll get to them as soon as possible. Cool. Thanks. See ya.